Well, good afternoon, good morning to everybody here. And if it's nighttime by where you are, thanks for coming and hanging out with us today. My name is Dave Holdorf. I am with Takeo Comfort Solutions, and welcome to Takeo Tuesday. Glad you all can make it right now. And as you're looking around and trying to find the other two amigos, they are unavailable. So it's going to be the Dave Show solo today. So I will be monitoring the questions and doing the presentation all at the same time today. So welcome for another edition of Takeo Tuesday, and it is our residential focus class today. So I see a bunch of people still logging in at the moment. Let me get my screen shared up for you guys. 1, 2, 3, 4. There we go. And we are rocking and rolling. So today residential class is air controlled and dirt separation in residential hydronics. So we're not going to actually talk about the separation components today. Today we're going to talk more about what it is and what's going on in our systems. And in 2 weeks time, we're going to go into a deep dive into how to get the air out. And mechanically how we're going to do all that and get the dirt and stuff out of our systems themselves. So that's what we're going to dive into in a couple of weeks. But today is all about air and dirt in our systems themselves and how it happens, how we get it in there, and what we can do about it. So if you understand how it gets in there, we'll also understand a better way to make sure it comes out, and also when we're troubleshooting systems and taking a look at what is going on. So I do want to say thank you for everybody joining us again for another edition of Takeo Tuesday. Greatly appreciate as everybody is slowly logging in. I see that the numbers are going up as we go through. So with that being said, I'm going to go through the normal stuff. And what do I mean by the normal stuff? All right. If this is your first time hanging out with us on a go-to webinar platform, let's make sure everybody understands and knows how to make the system work and get what you want to get out of it. So first, before we even get into the control panel, I would love if everybody can just treat this like any other training class, like we were there live in front of you. And make sure you got yourself a notebook, and a pen right here in front of you to write anything down. There will be some good nuggets, I hope, of information for you today. So write that down like you would any other class. Take your device if you can, put it on silent for the next hour, and you'll get back to everybody that calls in, or texts you, or emails you, or whatever's going on there. So be prepared, get nice and comfortable, get yourself a cup of water, a cup of coffee, whatever you're looking at. But now to understand how to use the control panel, what I would like everybody to do, if you can see this orange arrow pointing to the left, I would love for you to click on it and expand it out so it looks like this. When it's to the left, you don't see everything that I see here, and what you've got control over is your audio. So if you can't hear me correctly, make sure you've got your sound correctly turned on. You won't have the opportunity to turn your microphones on. Those are all muted by myself. You'll also see in the middle here a handout section. So we do have the newest catalog has been uploaded there, so you can download our newest catalog to take down. And to communicate with me is the questions chat area. That will look like a balloon question. Click on that, and you'll be able to communicate, type questions in, type answers in, and everything in between. So a couple people have already, but I just want to make sure that everybody is there and everybody can hear me and everybody is understanding what's going on. So if you can type in a quick, hi, Dave, thank you, Ken. Hi, hello, how are you? Just type something in there and make sure it's all working. So that would be greatly appreciated. And this way we all know that the system is working. So where I am on Long Island right now, it just literally 2 minutes ago decided to turn around and rain buckets. So I will periodically stop and check the questions and make sure everybody can hear me. I can see a whole bunch coming in from Steve and Craig and Greg and Mark Rosenberg. Yes, I got your number over here. Because of the storm that's coming whipping through Long Island right now, I just want to make sure I don't lose internet connection, and I'm talking to myself for a while. So excellent. Zaid, thank you very much for logging in and hanging out with me today. So if you are using a device, if you're on a device like an iPad or a tablet or something like that, things look a little bit different. Your control panel is going to be along the bottom, and you'll be able to see the screen, but you'll toggle between the camera and the presentation. The audio section, like I said, just making sure you've got the right sound hooked up, what headset you're connected to, The attendees, you don't see that part of it there, but this is where you go to questions. So you will have to toggle between questions and the presentation in order to type anything in for me. So with that being said, let's get going. Let's start talking about air and dirt separation today, or air and dirt in our residential hydronic systems. And make sure you type those questions in. I'm going to look at them periodically just to make sure there's nothing there, nothing to disappear down the list. So, have you got air in a system? And if you do, so what? All right. Well, let's think about this for a second. Well, air in a residential or any hydronic system for that matter is the bane of our existence, man. It is a pain in the neck, and when we've got air in our system, it just wrecks all kinds of havoc that we've got going on in there. Just a couple of things from our standpoint, from the TACO stand. You can start ruining pump efficiencies, meaning our wire to water efficiency of a circulator right now. You could start reducing it tremendously when you have air in a system itself. So your circulator efficiency, when we take a look at, say, a 007, 007 is a 27, I believe, 27% wire to water efficiency, meaning 27% of the electricity that goes into the circulator is used to move water. The rest is given off as heat in the motor itself. So we start having air in our system, and if we just had, say, a 4% solution in our water, all right, you're starting to decrease or decrease the efficiency of that circulator itself, and it can't move as much any longer. So we start ruining our efficiency and the pumping capacity also of the circulator itself. A couple other things. When we've got air in it, water's not going to move as fast, right? It's going to move much slower in our systems. And as we've said it before, these circulators can't pump air. They're not pumps, all right? It's a circulator. It's moving water in a circle. We just can't pump air, all right? We're not going to be able to pump in air, and that's important to understand as we start talking about and how we're going to pipe in our systems themselves too, all right? Another thing about it is that air is an insulator. All right, think about that for a second. Air is an insulator. All right, it does not transfer energy as well as water does. When you really think about it for a second, when we do heat loads, as we've talked about earlier in other sessions, and we take a look at a double pane window, for example, why is the R value of that window so high? Is it because of two panes of glass, or is it because of the air that's in the middle? It's not the glass. It's the air that's in between. When you get to a triple pane window, that R value now of that glass goes up because of that extra layer of air. It's an insulator. But if we have air in our hydronic system, it's not going to transfer as much energy as possible, all right, that we're looking for. So that could also be detrimental to the performance of our heating system just by having a little bit of air stuck in our water itself. And of course, the last thing that happens, which is going to be the second half of the class, is it could add rust in our system, because it's not water that's going to make the metal rust out, right? It's the oxygen that's in that water that is going to attack any of our steel and iron components in there and make rust. All right, oxidize. There we go. That was the word I was looking for. So it's not water that's oxidizing, it's oxygen, and that's oxygen's in the air, obviously. So we can constantly, start rusting out our systems and start killing them from the inside out. So that's when we have air issues and air challenges in there. How do we get rid of the air? What's the number one way to get rid of air in our hydronic systems out there, people? So let me just see any answers in there. Number one way that you all get rid of air. All right. Yes. Put something that has TACO. No, actually, I'm not even asking to put something in TACO. Nope. There's an easier and least expensive way to get rid of air. All right. An air release valve, a 4900, an air purger. Easier. And we all do it, right? Everybody does it. All right. You gotta purge. There you go, Ian. There you go. You gotta purge the system out. All right. That's how we get the air. Because when we start off with the system, it's completely full of air. We got to get all that air out. What we put in when we put in devices into the system, now we're getting the smaller air bubbles out. But the first thing we got to do is purge. And I want to show you this diagram right here. And this diagram comes with all our circulators. That's the installation instructions that come with every single circulator that we make. And we're giving you a quick and easy way to pipe out a system itself and to effectively try to purge. All right. So, and it has a bunch of steps in here to show you what to do, what valves to open, which ones to close in order to effectively help get the air out of the system itself. Right. So there's a little key there. So you see all the numbers on our valves and our purge valves here and our fast fill PRV up here, isolation valves on our circulators. And here's our air, here's our air eliminator with our expansion tank and whatnot. All right, but this is for purging, not getting the rest of that little bit of air out of there, right? So let's take a look and identify a couple of valves. So we have valve 1, which is on the return side of our boiler, valve 2 and 3, which is on either side of the circulator. And then of course we have valve 2 and 3 again for another zone if you've got additional zones in your system, if you're zoning by circulator here. We have our fast fill, our PRV here, right? So the steps: close valve 1, PV1, PV4, and valve 2. Okay. So we want to make sure we close a couple of valves, make sure we're isolated here for a second. Let's close off any of our additional valves and only purge one zone at a time. If you have multiple zones in your system itself, do one zone at a time and get all the air out of that loop before you move on to the next one. Then what we want to do is open up our fast fill. All right, do the override, throw the switch over and get that fast fill. We're not looking at just doing the little bit that the PRV is going to do to maintain, say, our 12 PSI in the system. Let's get everything opened up as full flow as we can. Now we're going to open up our boiler drain, and what's happening, right? Well, our water is going to start filling in. We start opening up valves on our zones, and our water flow is going to start flowing through the system itself. And if we have our fill valve here, all right, now a lot of times we show you trapping it into here too, same difference, really close to each other here. The water flows in one direction because we have check valves probably over there. And as it comes back to our zone, it returns here. Yes, we're going to have a little bit of air stuck in our boiler here possibly, but this will also, get taken care of by the vent themselves. So I hope that makes sense when you take a look at it. And like I said, we have this included with every single circulator. It's in the instructions. It's in the box inside there, So now my buddy Rick, who has, he's not able to join us today. He put together a quick little piping diagram, which I just think is phenomenal to way to think about it, because now you don't even have to worry about the air that's here, then stuck in the boiler system itself, is to put your boiler drain on the supply. So many people put it on the return side of the boiler itself, like I showed you earlier. But what if you were to put it on the supply coming out of the boiler, have a ball valve in between that and the air elimination, and where that water comes into your system, there's the only little bit of pipe that you're missing is right in between here. It is right in between. So if we stop and think about that for a second, right? And make sure your circulator is going to be in the off position. That's important. Make sure the circ is off. We don't want to start churning and really mixing the water and air together. Turn your circulator off for whenever you're doing any purging for that purposes, right? So the water is going to come in from here, come up. It can't turn right. We're going to close this valve down. It's going to go through our zone, come back from our system, and come right out of that drain valve right there. All right. So just as effective as I was showing you before. And again, if you had multiple valves, we're going to, multiple zones, shut off each zone, do one zone at a time. Really quick, effective way to help get that air out before we even think about putting in any air elimination devices after the fact. So this is your purging purposes. So I hope that makes sense for everybody, and think about different ways in trying to get that air out first. I know nobody really enjoys purging. It could be a tedious task, but if you don't do it well in the beginning, it could bite you later on in the end. So I want to make sure you get that initial burp of system flow going through there and those initial air bubbles out of your system itself. Now, another thing to consider to help the air elimination devices that you put into a system itself, to help those things do their job, is pump away. All right, if we're going to pump away from a system itself, all right, let's think about, why are we going to pump away? Why do we talk about pumping away all the time? Most importantly, it's to help the circulator itself, but it's also to help purge. All right. And one of those things to think about right there. All right. If we are pumping away and not from the boiler, pumping away doesn't mean pumping away from the boiler. Pumping away means pump away from your expansion tank. All right. Because the expansion tank is the pressure police in the system. That is controlling everything that you've got going on in the system itself. And your circulator is only a pressure differential machine. It can only add pressure to what it sees on the suction side of the circulator and add that PSI differential to the discharge size. And that's it, right? It's only a pressure differential machine. Right here at this point is going to be the lowest pressure in the entire system. It also happens to be the hottest water in the entire system when that boiler is up and running. So right here at this point is the hottest pressure and the hottest temperature and the lowest pressure. And with those two things combined, air wants to get out of solution. It doesn't want, it's much easier to get it out at the hottest and lowest pressure. All right, hottest water temperature, lowest pressure, that's when air wants to come out of solution easier. So we let these things do their job as effectively as possible, okay? So circulator placement, all right? So we talked about this real quick, but I wanna go into some more details so you can really see what I mean by it when we talk about pumping away, all right? Pumping away is pumping away from the expansion tank. But what if you were pumping towards the expansion tank, all right? Circulator's got to create that differential pressure. That's its job, and it can't raise the pressure in the system. It cannot raise the system pressure. That's the job of the PRV. The expansion tank has helped to keep the pressure under control in our systems themselves. What's the only thing the circulator can do? Like I said, it can just create a pressure differential. So what we call the point of no pressure change, all right, and pumping away and all this stuff, that very synonymous. You know, those things usually you don't have that conversation one without the other when we start talking about the point of no pressure change. So let's take a look at it for a second. So the point of no pressure change, like I said, is this point right there where you see your expansion tank is tapped into your system. That is the point of no pressure change because your expansion tank is acting as your pressure police here, okay? So the only things that can change pressure at the point of no pressure change, and you guys type in your answers also. I'm going to show off the first one here since I already hit the keyboard. You can add or remove water from the system. What other things can change the pressure at the point of no pressure change? All right, there's two more ways that you can change the pressure at the point of no pressure change. The first is to add or remove water from the system. So if you filled this system up, you got all the air out, and it's sitting there at 12 psi, how can you change the pressure? Well, I can add more water in there and the pressure will go up because water is incompressible. We can't compress water, so your pressure goes up. Or if you start draining water out of the system, the pressure starts to drop. All right, so that is one way. And there we go. Brandon got it exactly. Add or remove air from the tank, all right? Because the tank, what your expansion tank does, is an acceptance level, and it has to accept water into that tank itself. And so you've got that bladder on the inside that's pressurized to help push the water back into the piping system itself. So if you change the air pressure on there, you can also change the pressure at the point of no pressure change. All right. And then last but not least, answered by Paul and Andrew, heat the water so it expands. Hot water takes up more volume than cold water. So as the water heats up, it's going to expand and it changes the pressure in there. Now, what I want you to do is really look at those three things right there. Can a circulator do any of that? Can a circulator do any of those things there? All right. And I already told you before what a circulator does. It's a pressure differential machine. That is it. Circ can't do any of those things. So this is why we want to pump away. And let me give you a little more detail on that as we dive in. Remembering as I show you my examples here that the circulator always uses the expansion tank as a reference point. All right, so that expansion tank says, you know, I'm the pressure police in the system and the circulator must follow suit and understand what it's doing there. So take a look at a quick little piping diagram here. I'm looking at very simple stuff, very easy. All right, now I want you to imagine this loop of pipe going around a house. All right, it's going up 18.5 feet high. We're taking a look at a standard 2-story home, all right, where your circulator and your expansion tank is down in the boiler room. Now the circulator is off at the moment, and I have eliminated components just for clarity. I've gotten rid of air elimination devices. There's no vents in here. We don't have a PRV. We have no drain valves. We've got nothing except for a circulator and an expansion tank pipe completely filled with water. All air has been removed from the system itself. All right, no water, no air whatsoever, completely filled. And we have a couple of pressure gauges. All right, there's going to be 3 pressure gauges in the system, one on either side of the circulator and one at the high point of the house. All right, those are our 3 tappings for a pressure gauge thrown into the system. So let's take a look at what's going on. Right now, since the circulator is in the off position, it has a 0 PSI differential. Duh, right? Of course it's going to have 0 PSI differential. It's not running. So if you were to take a look at it and we had a standard expansion tank in the system set for 12 PSI, and as we did that, the pressure gauge is down here. Obviously, if the tank is at 12 PSI, our water is supposed to match our tank, is also going to be at 12 PSI. And when we take our readings on either side of the circulator, it's also going to be 12 PSI because one, the circulator is in the off position, okay? However, water's got weight to it, right? And 12 PSI is at the lowest point of the system. That's where we put our pressure gauges on. When we put a pressure gauge at the upper level of the house, the whole reason for the 12 PSI has to do with our circulator itself, because like I said, it just creates a pressure differential. And because of 18.5 feet high, all right, and the 2.31, that conversion, everybody knows that we've talked about it several times before. 18.5 feet high gives me an 8 PSI drop. Since it's 8 PSI drop, we end up with a 4 PSI on the upper level of the house. And this is what we want. We want to see 4 to 5 PSI at the highest point in our system in order to make sure that we can move water. Because a circulator doesn't pump anything, it's a pressure differential machine, and it needs to have pressure in order to move things around. All right, so right now, this is ideal. This is ideal that we want to see in our system when it comes to taking a look at the pressures. So we see 12 downstairs, we see 4 upstairs, but right now we are pumping into the expansion tank. All right, we're pumping into the boiler, so to speak, or into the expansion tank. Depending on where your expansion tank is, but I don't have a boiler here, so don't even think about it. So what happens when we turn that circulator on? All right, turn that circulator on. It will depend upon the type of circulator that's there, what size it is, all right, which is important. But remember, the expansion tank is our pressure police in the system, and that's still sitting there at 12 PSI. All right, that's important to understand. So which means if the expansion tank is the pressure police, what is the pressure gauge going to read on the discharge side of the circulator? Knowing that a circulator has to create a pressure differential, all right, has to create a pressure differential in order to start moving the water around. So what would the pressure be here on the discharge side of our circulator? What must that number be? It's got to be 12. If I've got 12 in the tank, it's going to be 12 on the discharge side. This is the pressure police telling everybody what else has to go on in the system itself. So we see 12 on the discharge side. Now, this circulator that we're using happens to be a 4 PSI differential circulator. All right, that's irrelevant on which model it is at the moment. All right, let's just think that this circulator has a 4 PSI differential that we're using in the system. All right, if it is a 4 PSI differential and a circulator must create a pressure differential, and the expansion tank has already set what the discharge side of the circulator is, what must the suction side of the circulator be? What must it be on this side of the circulator? All right. So I see Warren dropped in an answer. Excellent. Thank you, Warren. And wow, just like that, the sun's back out on Long Island. So I think I'm going to be okay. All right. So I don't think I'm going to be losing any power and any internet. Andrew, thank you very much. A couple of answers popping in there. I greatly appreciate it. I'm going to keep it on the edge for a little bit. I'm waiting for some more answers, making sure you guys are all there and not tapping away on your phone and checking your Facebook feed. I'm kidding if you are. It's your webinar, right? So Michael, thank you very much. Philip, awesome. So yes, you guys all got it right. I kind of led you through the answer really easily too, right? It has to be. It has to be 8 psi on the suction side of the circulator itself. All right, which, hey, in all intents and purposes here, that's cool. All right, that's cool. What's going on? We're going to move water. We're creating a pressure differential. However, think about the height of the system itself. If I have an 8 psi drop at this side of the system, all right, because it goes up 18 and a half, down here, it reads 8 because this is nice and level to that circulator. So it's going to read 8 here. But this is also an 8 psi add, right? So if it's an 8 psi drop based upon the height up, now it's an 8 psi add over here. All right, we have the potential. We have the potential to see 0 psi at the highest point. That's the issue that we run into when we start saying we're going to pump into the expansion tank. All right, with a 4 psi differential circulator. So that's where we see the potential issues. Doesn't always happen, because I know lots of people out there right now are turning around and saying, well, I've seen circulators on the return of boilers for decades, and it's worked for many, 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 many years, if not decades. And that's 100% true. I'll get there in a second. So let's say we just move the circulator 6 inches forward. 6 inches forward in the system itself, and put it on the other side of the expansion tank and pump away from that tank itself. Let's take a look at the numbers. Let's take a look at the numbers on what we see again. So circulator is in the off position, and we have our expansion tank as the pressure police sitting there at 12 psi. So since the tank is the police, it's the reference point, where do we start? We're going to see 12 psi now on the suction side of that circulator. And with the circulator in the off position, 0 psi differential at the moment, the discharge is going to be 12 psi, and the upper level of the house with an 8 psi drop should be bump a bump. Yes, that's right. You all said it in your head. It's going to be 4 psi. Identical to what we had before. Of course it's going to be. It's got to be, right? Because the circ's off. Doesn't know anything else. It's just sitting there by itself, nothing happening. You know, we don't have any hot water, or the water temperature's not changing. It's just sitting there. So this is what our designs call for. We always want to see 4 to 5 psi at the upper level of the house. Okay. So now let's go ahead and turn the circulator on. So we turn that circ on. All right, using the expansion tank again, 12 psi on the at the tank itself. The pressure police in our system, 12 psi on the suction side of the circulator. This circulator happens to be same circ, 4 psi differential. So now what do we see on the discharge side of the circulator itself? There it is, couple of answers banging in there real fast. You guys got it quickly. Excellent. Thank you, Warren and Kerry and Brandon. You got it. So Philip, Andrew, you put a question mark there? No questions, man. Yeah, 16 psi. Because now we did what, now the circulator added the pressure differential that it can do to the system to the starting point rather than detracting from it. So that means when we get to the highest point of our system, we see 8 psi at the highest point of the system itself. And now we're guaranteed to move water around. Now, if anybody has ever experienced where you have the potential of 0 psi up there at that highest point, a lot of times it's the highest point of the house, and some people start thinking, well, it's been off for a while, it must be air. And they go and purge the system out. And they start purging, and as they're purging, they're looking in the bucket, right? Always put your hose into the water of the bucket. Always start with some water in that bucket first. Put the hose end into the bottom of it and look at it and watch it. And what are you looking for when that hose is in the bottom of the bucket? All right, very important thing to look for. Here we go, Brandon. Exactly. You're looking for bubbles. Kerry, awesome. You look for bubbles. You don't look, the water's there, right? You're looking for any bubbles to come out of it. And if you were to happen to purge at this point, you would see no bubbles. What you could experience if this was a house, right, and you got the boiler in there, what are you going to experience? You're going to feel hot water coming back on the return side. So if you happen to purge that zone up on the second floor and the water starts to get warm and the pipes get warm, you're like, all right, I got it. I got the air out, we're moving heat, we're all good to go, which happens often, okay? Because the pipes got hot. You move the water around, all right? And that's why the pipes got hot. 20 minutes later, after you clean up and leave the house, it's not moving again, all right? So because remember, it's not an air issue, it's a pressure issue, all right? Putting a bigger pump in there does worse. Bigger circulator, meaning bigger PSI differential, will actually make the situation worse, because now you could, not that you could create vacuum. This is a little 125th horsepower circulator. You're not going to create a vacuum in here. And you can't put too big of a pump in where we're going to pump into our expansion tank, right? Remember, one thing, you can't pump into the expansion tank because this is a set volume of water that's sitting in here. If I pump water into the expansion tank and expand the bladder, what's behind it? You know, you took water out. I can't put air in, right? Because there's no way for the air to get in here. All right. I can't have vacuum because it's a 125th horsepower circulator. So with that being said, why has for decades pumping into the tank worked? Why has it worked so well for decades upon decades? Well, you got to stop and think about it for a second. Decades and decades and decades ago, what was the circulator of choice that was used on the return side? All right, and even mounted from the boiler manufacturers there on the return side. What circulator was there? All right, before the 007, Warren, before the 0025. All right, there you go, the B&G 100s. All right, we had the B&G 100s, the Takeo 110s, the Red Barons. Powerful circulators? No way. Very low PSI differential. So if we had a low PSI differential, like 1.5 PSI, all right, let's go back and take a look at the pumping into an expansion tank. All right, I'm showing you the numbers here. Let's make this number 2, a 2 PSI differential circulator. We got 12 on the discharge side. What would the suction side be? All right, if we had a 2 PSI circulator here, if I got 12 stuck here because the pressure police said so, yeah, we're going to see 10. We're going to see 10 over here, and therefore, what would we see up here? 2. It works. Where do we see 4 PSI differential circulators? Is that such a crazy number or crazy size circulator? Not at all. That's like our 3 speeds, right? 0015s circulators. 3-speed circulators can create that issue. So newer technology designs started to kill the designs of, say, pumping into the expansion tank and pumping away from the expansion tanks. So there's so many people out there that say pumping away is the only way possible. If you do anything else, you're a hack. No, it's just understanding the pressures in your system. All right, that's the important thing. We need to make sure we know what circulator is doing. 007, not a very strong pressure differential circulator. All right, 007's around 2. The old 100s and 110s about 1.5. Right, they only maxed out at about 7 foot ahead, where your 007 goes up to 10. Very flat curve. It's your steep curve circulators that have the high PSI differential circs that you need to watch out for. Now, with that being said, you pump away from a system, all right, it only adds to us and it takes advantage of what the circulator is going to do. So you never have to worry about that low pressure up in the attic space or up on the second floor itself. So I hope that makes sense. And by talking about this also, like I said before, is going to help us with air, getting the air out of the system. If you were pumping into an expansion tank and you think you have an air issue, it's not an air issue. All right. Just remember that it may not be an air issue, it's a pressure issue. All right. So yes, you can increase the pressure in the system to make sure that you don't see the 0 PSI at the upper levels of this house. But at that point, you understand what's going on. Don't keep purging. If you keep purging and you don't see air in the bucket, you don't have an air issue. All right, so let's talk about that pressure, all right, and talk about it with head loss, right? We talk about static head, all right, and that static head being 12 PSI in our system itself. Why is it 12 PSI? It's an 80% rule. 80% of our systems is going to be a 2-story home with a boiler in the basement, all right, getting to that 18.5 feet high. So that's why we do 12 PSI. Every single PRV that you touch, and all the manufacturers out there, They're all set for 12 PSI. Doesn't mean they need to stay that way. All right, they're just 12 PSI for the 80% rule to look at that 2-story home with a boiler in the basement. And here's that a conversion as I talked about before. 1 PSI equals 2.31 foot ahead, or 28 inches of water column is 1 PSI. So this is to keep the pressure up on the highest levels of the house. We stop and think about it for a second. Let's get some quick numbers here. All right, just ballpark it for a second. Let's think about that boiler in the basement and where that PRV is, all right, to the ceiling height in the basement. All right, and I just chose an arbitrary number 1 to keep the math easy in my head. Let's think about it's only 5 feet from the mount of the PRV to the ceiling level. What's the height of the first floor? I know a couple people are going to jump in 8 right away. Don't forget joists. All right, don't forget the floor thicknesses in there. So what's the height to the first floor? We're looking at 10. And I like to, yeah, and you guys know me, I like to keep the math easy. All right, I like to do the math, but I also like to keep it easy. So let's make it 10. All right, and then to the baseboard on the second floor, counting your joists, and to the level of the baseboard, let's call it 2 feet. Add that up. We go ahead and add that up. Easy enough, comes to 17. What are we going to do with that number there? Well, let's stop and think about that for a second. 12 PSI. Why 12 PSI? We can multiply that by our 2.31, gets us 27.72 feet. And you start thinking, okay, that's more than enough because we're only at 17. Well, you subtract 17 from 27.7 and you end up with 10.7. I don't have a slide with the math. I just got this memorized in my head. 10.7 left over. Divide that by 2.31, then that equals 4.12, which means that's the pressure at the highest point of the house. All right, so if you want to do some reverse math and figure out what pressure you need in the house to make sure you've got enough pressure in there to make sure you get enough height at pressure at the highest level of the house, that's your simple math, and that's why the 12 PSI. So I hope that makes sense for you all. All right, so that's our friction head. All right, is our that's the pressure drop of the pipe itself. So the two different things, just don't get them confused between static head and friction head. Friction head, we've done this many times. That's the pressure drop of the pipe itself. Static head, different animal altogether. All right, and then there's the pump head, and the pump head is when we're sizing circulators, making sure that we can satisfy that. You love those pictures, right, Warren? Google Images can do so much for you and make things so much more fun when you're doing webinars. So excellent, excellent. Another thing to think about, all right, when it comes to water itself is the solubility of air and water. And we've heard this term before, right? But I'm breaking open the book for you, all right? Breaking open the dictionary. And what is the definition of solubility? Just so we know and we're all on the same page. And yes, I'm going to break a taboo rule of ours that we do. We never read from the screen. I'm going to read from the screen. All right. So pulled it right out. Solubility is the ability of a solid, liquid, or gaseous chemical substance referred to as the solute to dissolve in solvent, usually a liquid, and form a solution. All right. That's the definition term. That's what's right out of the book. So just think about this. The solubility is the ability of the solid, liquid, or gas, air, to dissolve in water. All right. So that's what we're paying attention to. Let's try to get that air out. Where do we look at trying to get that air out, as I talked about it? All right. It's all about pressure and temperature. As I said before, it's all about pressure and temperature of the water itself. So here's a nice little chart that I happen to find, looking at percentages, all right, the solubility of air based upon temperature and then pressure when you look at these different curves. So if you really look at it, as the cooler it gets, all right, and as we see the pressure, all right, as the pressure increases, all right, we want the lowest pressure and the hottest water. We are usually around 180 degrees for our boiler systems themselves, right? 12 PSI gauge, which is about 24, 25 PSI air, PSIA, all right? We are looking right around here, just about 5%. So remember, we keep that number as low as possible, we'll be able to get that air out, all right, or get as hot as water. So if you're starting to look at a boiler that maybe you don't want to run it too hot, run it hot in the beginning to get the air out. All right. If you keep the water cool or you try and purge in the summertime, but don't want to turn the boiler on and you don't want to put any heat in the house itself, you're still going to leave a lot of solution, a lot of air in solution itself. It doesn't come out. Crank up that temperature, crank up that, and get the pressure as low as possible. All right, in order to get it out. So the lower the pressure, the less soluble it is. My X is at 2%. Okay, I see what you're saying. Yeah, I'm following the curve. All right, so it's just about 5% here. Excellent. All right. How we doing there, people? I see everybody's typing in questions and comments and stuff like that. So greatly appreciate it. And seeing you guys interact with me, which is really good, really good. I'm doing good today. Not bad, not bad. Yes, I'm solo today, Andrew. So John, believe it or not, John is at the factory. He left New Hampshire, the home office, and went down to Rhode Island, and they're having some meetings today. So he was not able to join us today for that reason. So, but he got out of the building. It was great. I was talking to him yesterday. We did a little Instagram live, and we did a little factory tour yesterday. So it was really cool to see the inside of the building. I hadn't been there in a while. And Rick is on vacation this week. So they said, Dave, go, you're flying solo today. No problem. So I greatly appreciate you guys hanging out with me today. So as we move along, dirty water in the boiler. I know. And I'm sorry if I did that to you and you're just about to have lunch or are eating lunch at the moment. Hopefully you didn't spit everything out on the person next to you. Yeah, well, that's a really light beer there. I'm not sure, that's really watered down. But anyways, dirty water in our systems. So what, right? We've seen dirty water. Water gets dirty in our boilers all the time. Let's think about a couple of things, and let's think about, maybe you've run into this before, but didn't really know why you had issues in your system. So water quality can really affect a lot of things, and it builds on itself over time. So if you happen to find pump seals are leaking, especially in the three-piece circulators, right? Like the B&G 100s, the Takeo 110s, or the Red Barons, all right? If you happen to see circs not lasting as long because the seals are leaking on those three-piece circs, you might have a water quality issue, right? And may need to be addressed. You find flow checks, not just the IFCs that we have built into circulators, but also flow checks are getting hung up. All right, either in the open or closed position. So you got to grab your IFC, start giving it a couple of wraps, right? Your check valves, you start hitting it a little bit with whatever tool you got in your hands and see what's going on. And then if not, you start cranking them open or see what's going on inside. And then take it apart. You look at it like, oh, it's all moving. Well, it's just because the water quality is hanging things up inside. All right, circulator seizing up. Right, and we experience seized circulators all the time, but remember one thing about circs: the tolerances between the impeller and the casing that you see here is really close. Not a very far distance between the two of them. So you start to seize up circulators. If you seem to be replacing circulators often, every year or two, on an older system, it could be dirty water. And I know a lot of people turn around and say, oh, the quality is just not the same as it used to be, or must be a bad batch. How could there be a bad batch 2 years apart from each other? Okay. Things like that. So when you start seeing circulators being replaced a little more often, all right, you're seeing zone valves getting hung open, all right, or stuck closed is also a water quality issue. All right, here's another one, low water cutoffs. All right, your low water cutoffs are getting premature. What's the word I'm looking for? You're getting activations when there's no problems. I can't think of the word. It was there and just disappeared. It just said goodbye. Anyways, so yeah, your low water cutoff, your probes are going to get fouled up. It's going to get a coating on the outside of it, and it may not have the proper readings, and you're going to get, they're going to trip out. Okay, yeah, the water quality is just not what it used to be. Exactly, Colin. Yeah, we're thinking we got, these things are garbage. Let me put a different one in there. All right. And you put the whole new one in there and it lasts a couple more years. All right. Until the probe starts to get coated again and starts fouling and also giving you a bad issues. Right. So you start seeing heat exchangers and pipes getting plugged. You may not notice that because we're not necessarily cutting open the heat exchangers. So it's a thing that happens slowly over time. All right. So what? All right. So what if it does? Let's take a look at a couple of things. All right. And I found that I got a couple of pictures from friends of mine on cutting open boilers and taking a look at the inside. And we're taking a look at a couple of ModCon boilers here. Friends of mine from NTI sent this over to me. Now this happens to be a boiler 12 years in operation. Well, that's good. So what? Still got plenty of water flow. The heat loss wasn't that high. The boiler was oversized. We still got enough to go. That's a lot of restriction in there. And just because you think you got enough flow there, no, it's actually already been affecting a lot of things in the house. And you think the homeowner wants to go and replace that boiler after 12 years? All right. He had that old cast iron boiler there for 30 and 12 years. And I spent twice as much for this one on the wall of my house and I got to replace it again. Might as well go ahead and keep it, go back to cast iron, right? Now this one's only 3 months in. Look at that one, 3 months into operation. All right. And dead. All right. And that's when somebody just went ahead and just took the system itself, closed a couple of valves, pulled the boiler, put a new one in, opened those valves back up again. Right. Kept all that same dirty water floating around. All right. Here we got another one. All right. Bottom. All right. A lot of dirty water in there. All right. So we're looking at some fouled heat exchanger, pinhole. All right. Pinholes in here. And that's because you got superheated now. Remember, these things transfer heat so fast, all right, into the water itself. That's why we have such a low content of water in here, but we got to make sure we move it away. All right. And now when we start having all this debris and scale and stuff like that on the inside, it can't have that heat transfer. So we start to fatigue the metals themselves. So, and having other issues. I'm not sure the age of this picture here. All right. So, but other, and here we'll take a look at it from the inside. Taking a look at it from the inside, you can see that that crack going on there. All right, and where the leak is occurring. So, because of that concentrated heat buildup right there at that point, and failing that heat exchanger. So, your fire tube or your water tube heat exchangers, they're both susceptible to it. So, not to say it's only susceptible to our ModCon wall hung boilers, our newest and greatest boilers that we have out there. Cast iron is just as problematic that you can run into. Cast iron boilers have changed a lot over the years and are also susceptible to damage from dirt and magnetite and all the stuff in between here and clogging up systems and heat transfer. You start looking at this boiler here. Here's your cutaway. Look at that. Completely plug solid. This is, I think, if I remember correctly, this is about a 4-year-old boiler. All right, and it's plug solid down here at the bottom. All right where the fire is. Okay, so we're wondering why we're not getting heat transfer and what's going on. So they cut it open and took a look at it, and we're looking at a plug system again, keeping that dirty water in the system itself, and not cleaning it beforehand, or not draining and purging and treating the system itself. So, our boilers have changed a lot. We start taking a look at some of these old boilers out there. And I remember hearing the terminology when I was in school and, looking at mud drums, or mud legs, they were designed to collect all that stuff away, sitting at the bottom of the boiler. So, but they were bigger, right? There was more cast iron, that the heat wasn't there. As our boilers are starting to get smaller and smaller and more efficient, all right, that's when we start losing the places for all that dirt to fall and collect and hide. So now water quality is also just as important in our cast iron boilers as it is with our ModCon boilers. Just something to really, really remember and think about. So I grabbed this chart. This was an excellent looking chart, and let me see if I can remember it now. All right, as we start taking a look at water temperature, all right, what we're seeing here is the higher the temperature, the more scale can actually come out of solution. right? As I said before, hotter water is less soluble, right? And stuff will come out of solution. Any of our dirt and any of our composites or any components that are in the water are going to come out of solution relatively easily. And as the higher the temperature goes up, you can see the percentage of scale forming on there. And once we start raising that scale up, then we start losing that efficiency. We start losing the efficiency. So that boiler, that even that cast iron boiler that went in at say 87% efficiency, over some time, it's starting to lose its effectiveness. All right. And that's okay. It's big enough. As we've seen, we want to go small as possible. One, for cost of the darn boiler, the efficiency of the boiler, and moving that thing around. Okay. So just a bunch of things to talk about and think about when we are looking at our boiler systems and the boiler water. All right. We got to think of that water as a system component. We always think about components themselves and the quality of the materials that we're putting into somebody's home. The water is just as important as any other component. All right, whether it's going to be a circulator, whether it's going to be an ECM circulator for the efficiency, it's going to be a wall hung boiler for the fuel consumption. Okay, I'm going to go zone valves rather than zone circulators because I want to keep the power consumption down low. I'm going to go radiant floors because I want more efficiency that way. Let's think about the water quality, all right, and also getting the air out. Two very, very important components in there, and sometimes overlooked and not thought about a little bit deeper. Yes, these are weird things that I think about when I used to drive and be sitting in the car for hours upon hours on end. So, but still things to pay attention to. So what do we do about how to get that stuff out of there, right? One of the things, flush and clean the boiler, all right, or the system itself, not just the boiler, but the system. Before you go put a new boiler in there, yes, there's plenty of chemicals that are out there, or just, sometimes just doing a drain and flush doesn't necessarily get everything out. So one thing to think about there. And every time you drain water out and you put water back in, I forgot to mention this from the air side of things. All right. When you bring water in from the street, it has about 4% air in it. 4% air is in that fresh water coming into it. So we need to make sure we get that air out again later. Okay. So flush and clean your systems out. Yes, there's plenty of chemicals that you can put into it. A lot of chemical manufacturers that have some tremendous information out there on what to use, how to put it into the systems, what its benefit is in different applications. So pay attention to those manufacturers, what they have and what they can offer for you. All right. And then when it comes to really cleaning and then getting the solids out of the water itself, on a regular basis as the systems get older, then we start looking at mechanical removal in our systems. And that's what we're going to go through next week, 2 weeks from now, I'm sorry. 2 weeks from now, we're going to start talking about how to get the air out, what components to use. We're going to do a deep dive into all that stuff in a couple of weeks. With that being said, all right, I'm polling through. I don't see any real major questions coming in, but if you have them, type them in. Greatly appreciate everybody hanging out, but I do want to say first, thank you to everybody for coming and hanging out today. Greatly appreciate you still enjoying the Takeo Tuesday series. Next week's class is commercial. We're switching over to the commercial side. You'll see Rich and Brett next week, and they're doing a deep dive into the vertical inline pumps, our KVKS series circulators. I may have to get there myself because I don't know what the difference is other than a V and an S. Kidding. So that's going to be next week. 2 weeks from now, we'll switch back to the residential side. I'll be presenting again, and hopefully I'll have Rick and John with me again. So on June 29th, we're going to do a deep dive into the air and dirt separators themselves, going from the simple basics 400 vents up to our enhanced air separators and our dirt separation systems. So we're going to dive into those pretty deep into the components, how to use them, how to troubleshoot them, how to take them apart, how to clean them, everything about them. So as I'm sitting here talking along and rambling at the same time, I'm not rambling, but I'm just waiting for you guys to type in any questions if you got. Was that a picture of copper pipe scaled up? I did have a picture of copper pipe. A lot of sediment was in that one. Probably more of a plumbing pipe than it was a heating system pipe itself. it looked like to me, but it was, I think it got the point across. All right. In there itself. So excellent. Thank you, Greg. Al, thank you very much. Warren, greatly appreciate it. Philip, thank you very much. This was a fun class to put together and really dive in a little bit deeper. Greatly appreciate it. Do any of the chemical treatments affect the system like glycol? Typically not. The manufacturers are going to recommend which ones to which. I'm not a chemical guy myself, so I don't know enough about it, Kerry. So I couldn't tell you one way or the other. I'm sure they have some solutions. It depends on what the treatment is and what you're trying to do. If you're looking to clean a boiler out, you probably want to have it straight water for a temporary run for about a week or so. I know there's some chemicals you pump in, let it go around for a week or so, then drain down, and then you have a treatment system, not just a cleaning system. So that would work in that respect. Excellent. Ian, thank you very much. Cheers, Andrew. Excellent. Michael says, is 4% of the air in street water a problem for purging? Not necessarily, because it's a small percentage. That's where the air elimination is going to come into play. Your purging is getting out the big percentage of air. All right, the 4% that's 4% in water is now when you go and heat up that water and then put in your air elimination device is going to help that out. But I just remember, some guys will say, well, I've purged and purged and purged and I still got air. Yes, you do. All right. If you have no way for the air to get out, it's going to get stuck in there. And that's when I run into some people that aren't putting in some sort of air elimination device or having piping issues where the boiler's not piped properly to help get that air out. So excellent question there, Mike. Greg, you're very welcome. Sean and Colin, greatly appreciate it. Thank you so much for coming and hanging out with me today. Now, don't forget, I did have our latest and greatest catalog. So from the last class that we did, last Take-O Tuesday, we did not have this. This just came out. So it is our 2021 version catalog is in there. So in the handout. So if you wanted to get your hands on that, go for it. And if you needed a hard copy, get in touch with your rep. They should be getting them shortly. They don't have them today because we just got the PDF out to everybody. And we will be printing and getting them out. So if you want a hard copy, contact your local rep agency. They should be getting them soon. So that was a lot of stuff. And I talked really fast. I got to remember to slow it down, but it's hard as a New Yorker. I just talk fast. So anyway, everybody, thank you so much for hanging out. Look forward to seeing you in 2 weeks. Don't forget the commercial guys and hang out with them if you'd like to learn something about the KVKS circulators. Please hang out with those guys, and I'll see you in 2 weeks. Enjoy.